A board has 16 squares as shown in the figure, 4 rows and 4 columns. Out of these 16 squares, 2 squares are chosen. Then the probability that they have no side common. So we have total 16 squares in it. 2 squares are chosen. So total number of ways of selecting 2 squares is 16 C2. That is 16 factorial divided by 16 minus 2, that is 14 factorial into 2 factorial, that is 16 into 15 into 14 factorial divided by 14 factorial into 2. So here we can write 15 8s are 80 plus 40 120. So 120 possible ways are there in which we need to find no side is in common. So let us take the complement. Let's consider this is A, say this is B, C and D. Let's consider one vertical, and we can find that with adjacent, AB is adjacent, BC is adjacent, and CD is also adjacent. So these are the three adjacent from one column. And similarly, if I consider this is E, F and G from the row AE adjacent, EF adjacent and FG, they are also adjacent. So clearly we can say that in a row, in a column 3 are there, in a row 3 are there. So total 4 rows and 4 columns are there. So we can say adjacent squares can be determined by taking 4 rows, that is 4 into 3 possibilities, or columns also 4 into 4 columns are there and again 3. So 4 3s are 12 plus 12, that is 24. So total 24 adjacent squares we can find from the 16 squares from the given figure. So since we need, there is no common side, so therefore the required probability can be taken as 120 minus 24. We have to subtract 24 divided by the total, that is 120. So which is 96 divided by 120. So 96 divided by 120, we can write here 4 how many times? 4 2s are 4 4s are and again 4 30 times, or we can write 2 12 times, 2 15 times, or we can write 3 4 times and 3 5 times, 4 by 5. So 4 by 5 is the answer, which is option D. We need to find the length of the chord of an ellipse x square upon 4 plus y square upon 2 is equal to 1, and whose midpoint of the chord is given 1 comma 1 by 2. And we know that the equation of the chord of an ellipse x square upon a square plus y square upon b square is equal to 1, and whose midpoint is given h comma k will be given by t is equal to s1, that is hx upon a square plus ky upon b square is equal to h square by a square plus k square by b square. So here we can say the equation of chord so we can let x upon 4 into h value is 1 plus y upon 2 into 1 by 2 is equal to 1 square by 4 plus 1 by 2 whole square divided by 2, that is x upon 4 plus y upon 4, which is equal to 1 by 4 plus 1 by 8, that is 2 plus 1 3 by 8. So here we can write 2x plus 2y is equal to 3, or this can also be written 2y is equal to 3 minus 2x, or y is equal to 3 minus 2x upon 2, or y is equal to minus 1x plus 3 by 2. Now to get the length of the chord AB, we have to solve with x square upon 4 plus y square upon 2 is equal to 1, and y is equal to 3 minus 2x upon 2. So that we can write x square upon 4 plus 3 minus 2x upon 2 whole square divided by 2, which is equal to 1, and simplifying you get x square upon 4 plus, we get 9 plus 4x square minus 2 3 is 6 2 is 12, x upon 8 is equal to 1, or this can also be written 2x square plus 9 plus 4x square minus 12x, which is equal to 8, or we can write 6x square minus 12x, and here 9 minus 8 plus 1 is equal to 0. So this is a quadratic equation in x we got it, so that the sum of the roots, let us consider x1 and x2 are the roots. So sum of the roots is equal to minus b by a, that is minus of minus 12 divided by 6, which is equal to 2, and product of the roots x1 x2 is equal to c by a, that is 1 upon 6. So that we can write the difference of this numbers x1 minus x2 whole square is equal to x1 plus x2 whole square minus of 4 times of x1 x2, that is 2 square minus 4 times of 1 upon 6, that is 4 minus 2 by 3, that is 12 minus 2, that is 10 by 3. So we got x1 minus x2, which is equal to under root of 10 by 3. We got the difference of x coordinates in from the chord, and we know that the length of the chord AB is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. So which can also be written as under root of x2 minus x1 whole square taken common 1 plus y2 minus y1 upon x2 minus x1 whole square, which is nothing but the slope of the chord, so that we can write slope of the chord is equal to minus 1. So mod of x2 minus x1 root of 1 plus m square, so that we can find length of the chord, which is equal to mod of x2 minus x1, that is root of 10 by 3 into under root of 1 plus m square, that is 1 square, which is root of 10 by 3, root 10 by root 3 into under root of 1 plus 1, that is 2. So rationalization will get root 2 into root 5 into root 2, multiply and divide with root 3, so that root 2 into root 2 will become 2, and root 5 into root 3 will become root 15, divided by root 3 into root 3 is 3. So 2 by 3 root 15 units is the answer, which is option C. Option C is the answer, 2 by 3 root 15. Given in the expansion of 1 plus x whole power p into 1 minus x whole power q, the coefficients of x and x square are 1 and negative 2 respectively. Then we need to find p square plus q square. So we can write 1 plus x whole power p is equal to 1 plus p into x plus pc2 x square, and so on. The last pcp, that is 1 x to the power of p. Similarly, 1 minus x whole power q, we can write 1 minus qx plus qc2 x to the power of 2 minus and so on, plus or minus 1 or minus 1 whole power minus 1 whole power q into x to the power of q. And clearly we can say that to get the coefficients of x from the product 1 plus x whole power p into 1 minus x whole power q, to get the coefficient of x square, coefficient of x, so we need to multiply the constant with the x term, or multiply the x with constant term, so that we can get 1 into negative q is minus q and p into plus 1 is plus p, and which is given as coefficient is 1, that is p is equal to 1 plus q, or we can write q is equal to p minus 1. And now coefficient of x square, to get the coefficient of x square we need to consider the constant with multiplied with x square, so you'll get qc2, and x term must be multiplied with the x term again, so we can write p into q minus q, that is minus pq, and x square term should be multiplied with the constant, so we can write pc2 plus pc2, and which is given to be minus 2. So we can write qc2 as, we can write nc2 is equal to n factorial by n minus 2 factorial into 2 factorial, that is n into n minus 1 into n minus 2 factorial divided by n minus 2 factorial into 2 factorial, which can be written as n into n minus 1 divided by 2 factorial. So here we can add q into q minus 1 divided by 2 minus pq, and here we can add p into p minus 1 divided by 2, which is equal to negative 2, and we have q into q minus 1 divided by 2 minus p, we can write it as 1 plus q into q, and again here p we can write 1 plus q, and p minus 1 we can write it as q divided by 2, which is equal to negative 2. Let us solve it. So q into q minus 1 minus 2 times of q into 1 plus q, and again plus q times of 1 plus q, which is equal to negative 4. Or let us simplify. Q square minus q minus 2q minus 2q square plus q square is equal to negative 4. So q square plus q square and again minus 2q square gets cancelled, and here minus q minus 2q, that is minus 3q minus 3q, which is equal to, sorry, minus 2q, we can write minus 2q is equal to negative 4, which implies q is equal to 2. So we got the value of q is 2, and now p is equal to 1 plus q, that is 1 plus 2, which is equal to 3. So we got p value is 3 and q value is 2. And now we need to find p square plus q square, which is equal to 3 square plus 2 square, which is 9 plus 4, which is equal to 13. So 13 is the answer, which is option B. We need to find the number of complex numbers z satisfying mod z is equal to 1 and mod of z upon z bar plus z bar upon z, which is equal to 1. So let us consider z is equal to x plus iy. so that mod z is equal to 1, we can write it as x square plus y square under root is equal to 1. So x square plus y square is equal to 1, which is a circle, center 0 comma 0, and radius is 1 unit. And also z upon z bar plus z bar upon z, which is equal to 1, we can write it as z square plus z bar whole square divided by z into z bar mod is equal to 1. Since we know that z into z bar is equal to mod z square, mod z is nothing but 1. So we can write it as z square plus z bar square mod is equal to 1. When z is equal to x plus iy and z bar is equal to x minus iy, so z square we can write it as x square plus iy whole square, we can write it as minus y square plus 2xyi, and z bar square we can write it as x square minus y square minus 2xyi. If we add both, z square plus z bar square, which is equal to 2 times of x square minus y square. So here we can add 2 times x square minus y square mod is equal to 1. That is x square minus y square, which is equal to plus or minus 1 by 2. So x square minus y square is equal to 1 by 2, or x square minus y square is equal to negative 1 by 2. These both are hyperbolas. X square by 1 by 2 minus y square by 1 by 2 is equal to 1, or x square by minus 1 by 2 minus y square by minus 1 by 2 is equal to 1. So both are hyperbolas, and this is a circle. I can write these are hyperbola and its conjugate. So two hyperbolas are there, and the circle, we can just understand one circle and one hyperbola, and since the vertex are coming 1 by 2 comma 0 and 0 comma 1 by 2, so which is inside the circle because the radius is 1 unit, and one more is a circle and its conjugate hyperbola, again the vertices 0 comma 1 by 2 and 0 comma minus 1 by 2, so which are inside the circle. So clearly we can see that there are 4 points of intersection. This is 1, 2, 3, 4, and here 5, 6, 7, and 8. So there are 8 solutions from the two diagrams. So we can see the number of complex numbers satisfying both the equations are 8. So which is option D. Option 4 is the answer. Given the range of the function f of x is equal to 6 plus 16 times cos x into cos pi by 3 minus x into cos pi by 3 plus x into sin 3x into sin cos 6x for all real numbers be alpha comma beta, then we need to find the distance of the point alpha comma beta from the line 3x plus 4y plus 12 is equal to 0. So here we know that 4 times cos x into cos pi by 3 minus x into cos pi by 3 plus x, which is equal to cos 3x. So by applying this property here, we get f of x is equal to 6 plus 16, we can write 4 times, that is 4 times of 4, that is cos 3x into sin 3x into cos 6x. which can also be written 6 plus 2 times of 2 cos 3x into sin 3x into cos 6x, which is equal to 6 plus 2 times of 2 sin 3x into cos 3x is sin 6x into cos 6x, because sin 2a formula we know, 2 sin a into cos a. So here we can write 6 plus again sin 2 into 6, that is 12x. And we know that sin, either it is x or sin 12x, lies between minus 1 and plus 1. Now adding 6, so minus 1 plus 6 is less than or equals to 6 plus sin 12x is less than or equals to 1 plus 6, that is 5 is less than or equals to f of x is less than or equals to 7. So the range of f of x is 5 comma 7, which is given as alpha comma beta. So therefore alpha comma beta point can be taken as 5 comma 7. So now we need to find the distance from this point upon the line 3x plus 4y plus 12 is equal to 0. We know the perpendicular distance from the point x1 comma y1 upon the line ax plus by plus c is equal to 0 is given by ax1 plus by1 plus c upon under root of a square plus b square. So here we can write the distance. The distance from the point 5 comma 7 upon the line, we can write it as 3 times of 5 plus 4 times of 7 plus 12 divided by under root of a square, that is 3 square plus 4 square, which is equal to 15 plus 4 sevens are 28 plus 12 divided by 16 plus 9 25, square root is 5. So here we can write 30 40, 40 plus 15 is 55 divided by 5, which is equal to 11. So 11 units is the answer, which is option A. Given the shortest distance from the point a comma 0 to the parabola y square is equal to 4x, then the equation of the circle passing through a comma 0 and the focus of the parabola, having its center on the axis of the parabola. Its center is on the axis. Let's take this point as C. So we know that in parabola y square is equal to 4ax. We can say that the focus is a comma 0 and parametric coordinates we can write at square comma 2at. So here in this parabola y square is equal to 4x. So here a is equal to 1. So the focus can be taken as 1 comma 0. So here 1 comma 0 is the focus. And a comma 0, so the parametric coordinates we can write it as 1t square, that is t square comma 2t. Let's take a tangent at this point. So which cuts the x-axis at a point, and equation of the tangent also we can write. Equation of the tangent we can write it as y1 is equal to 2a of x plus x1 is the equation of tangent at the point. So here the point is t square comma 2t. So equation of tangent we can write y into 2t is equal to 2a times, so a is 1 here, 2 into x plus t square. So we can cancel here 2. So we can write the equation ty is equal to x plus t square. This is the tangent equation. This tangent cuts the x-axis at a point where y is equal to 0. So put y is equal to 0 in the tangent equation to get the value of x coordinate. So we get 0 is equal to x plus t square. So x is equal to negative t square. So we got this point, say B, minus t square comma 0. So that we can find the slope of PB is slope of line joining 2 points y2 minus y1 divided by x2 minus x1. So we can use here 2t minus 0 divided by t square minus of t square, minus of minus t square, that is plus t square. So we can get 2t divided by 2t square, which is 1 upon t. Say this is m1. Similarly, since PA is perpendicular to PB and slope of PA is equal to, so we can write y2 minus y1, that is 2t minus 0 divided by t square minus a, that is 2t divided by t square minus a. Say this is m2, and we have the relation, since they are perpendicular, product of their slopes is equal to minus 1, m1 m2 is equal to minus 1. So 1 upon t into 2t divided by t square minus a is equal to minus 1. So which implies a minus t square is equal to 2, or a is equal to 2 plus t square. So we got a in terms of t square. Let us find the value of t. So use the relation, since it is a right angle triangle PAB, it's a right angle triangle. So we have AB square is equal to PA square plus PB square. Here AB square is equal to, so we can write the distance between the 2 points a comma 0 and t square minus t square comma 0, the square. We can write it as a plus t square whole square, and a value is nothing but 2 plus t square. So we can write 2 plus t square whole square, that is 2 plus 2t square whole square. So here we can write it as 2 2s are 4, and here 4t power 4, 2 2s are 4 2s are 8t square. This is AB square. And similarly PA square we can write, since the shortest distance is given 4 units, so we can write 4 square is 16, and PB square we can write t square minus of minus t square, that is 2t square whole square, and 2t minus 0 whole square, that is 4t square, which is equal to 4t power 4 plus 4t square. And hence we can use the relation AB square, that is 4 if I take common, 4 times of 1 plus t power 4 plus 2t square, which is equal to PA square, that is 16 plus 4 times of, here also 4 I can take common, 4 times of t power 4 plus t square. So here 4 I can cancel, 4 ones are 4 4 times, and here 1. So I can write directly 1 plus t power 4 plus 2t square is equal to 4 plus t power 4 plus t square. So here t power 4, t power 4 gets cancelled, and 2t square minus t square, that is 1 times t square, is equal to 4 minus 1 is 3. So t square value got it as 3. So which implies a is equal to 2 plus t square, that is 2 plus 3, which is equal to 5. So we got the point A 5 comma 0 and A is 1 comma 0. So these are the two diametric endpoints. We can find the equation of the circle. We know that equation of a circle having its diametric endpoints as x1, y1 and x2, y2 is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2. So here are the two diametric endpoints 1 comma 0 and a comma 0. So we can write the equation as x minus 1 into x minus a, that is x minus 5, plus y minus 0 into y minus 0, which is equal to 0. So we can write x square minus x minus 5x plus 5 plus y square is equal to 0. So we can write x square plus y square minus 6x plus 5 is equal to 0, which is our option C, option 3. Option 3 is the answer. Given limit extends to infinity, this expression can also be written as limit extends to infinity 2x square minus 3x plus 5 divided by 3x square plus 5x plus 4 into limit extends to infinity 3x minus 1 whole to the power of x by 2 divided by 3x plus 2 whole to the power of again x by 2. And we know that when limit is approaching to infinity, x is approaching to infinity, ax square plus bx plus c divided by some dx square plus ex plus f, we can write it as a by d answer. Since both the degree of the numerator and denominator is same, we can take the leading coefficients ratio a by d. So here we can say the answer is here 2 and here 3. So coefficient degree is same, so we can write 2 by 3 is the answer. And here we can write limit extends to infinity. If I take 3x whole to the power of x by 2 common, so I can write 1 minus 1 upon 3x whole to the power of x by 2. Similarly in the denominator, 3x whole power x by 2 if I take common, so I can write 1 plus 2 by 3x whole to the power again x by 2. So that we can cancel 3x power x by 2, 3x power whole power x by 2. And we can also say that as extends to infinity, the numerator we can say 1 minus 0 whole to the power of infinity, that is 1 power infinity form. Similarly, the denominator is also 1 plus 2 upon 3 into infinity, that is 1 plus 0 whole to the power infinity. Both are in the case of 1 power infinity. We have limit extends to a f of x power g of x whenever it is in the form 1 power infinity. So we can also express it as exponential of limit extends to a f of x minus 1 into g of x. So here we can apply it 2 by 3 into exponential of limit extends to infinity, the numerator part 1 minus 1 upon 3x f of x minus 1 into x by 2. Similarly in the denominator also exponential of limit extends to infinity 1 plus 2 upon 3x minus 1 whole to the power x by 2, which is equal to 2 by 3 into exponential of, so here 1 minus limit x tends to infinity minus 1 by 3x into x by 2 divided by exponential of limit x tends to infinity 2 upon 3x into x by 2. So here x and x get cancelled. So the numerator is minus 1 by 6 and the denominator is 1 by 3. So which is equal to 2 by 3 into e to the power of minus 1 by 6 divided by e to the power of 1 by 3. That is 2 by 3 into 1 upon e to the power of 1 by 3 plus 1 by 6. That is 2 by 3 into 1 upon e to the power of 3 by 6. That is 1 by 2. So that is 2 upon 3 root e. So 2 upon 3 root e, which is option C, option 3. Option 3 is the answer. Given a rod AB of length 8 units, it moves such that it ends A and B always lies on the line x plus y, x minus y plus 2 is equal to 0 and y plus 2 is equal to 0 respectively. And the locus of the point P, let us consider h comma k. Point P is h comma k, the locus of this point, which moves in such that the rod divides internally, this P divides the rod AB internally in the ratio 2 is to 1. So 2 parts and AP is equal to, we can write AP is to PB is equal to 2 is to 1. So let us consider the general point on A. Since x minus y plus 2 is equal to 0, let's consider x coordinate is A. X minus y plus 2 is equal to 0. So A minus y plus 2 is equal to 0. So which implies y is equal to A plus 2. So we can write the point A as A comma A plus 2. And the point B, it is on the line y plus 2 is equal to 0. So y is equal to minus 2. And let us consider the x coordinate is B. So B comma minus 2 is the point B. So that the point P h comma k can be given as 2 times of x coordinate, that is 2 times of B plus 1 times of A divided by 2 plus 1 comma 2 times of the y coordinate, that is minus 2, and 1 times the y coordinate of A, that is A plus 2 divided by 2 plus 1. That is h is equal to 2b plus A divided by 3, which implies A plus 2b is equal to 3h. Also, the second coordinate k is equal to A minus 4 plus 2, that is minus 2, A minus 2 divided by 3. So which implies A minus 2 is equal to 3k. So A is equal to 3k plus 2. Let us substitute A is equal to 3k plus 2 here. So we can write 3k plus 2 plus 2b is equal to 3h. So that 2b is equal to 3h minus 3k minus 2, or b is equal to 3h minus 3k minus 2 divided by 2. So we got A value, B value in terms of h and k. And since the rod length is AB is 8 units, so the rod AB is equal to 8 units. So we can write AB square is equal to 64. So the distance between the 2 points So we can write a minus b whole square plus a plus 2 minus of minus 2, that is a plus 4 whole square, which is equal to 64. So here a minus b we can write it as 3k plus 2 minus 3h minus 3k minus 2 divided by 2, or we can write 6k plus 4 minus 3h plus 3k plus 2 divided by 2, that is 9k minus 3h plus 9k plus 6 divided by 2. So this is a minus b, and a plus 4 we can write it as 3k plus 2 plus 4, that is 3k plus 6 a plus 4. Now we can simplify and write minus 3h plus 9k plus 6 whole square divided by 4 plus of 3k plus 6 whole square is equal to 64. That is, so if I take 3 common, so 3 square 9 can be taken outside. So 9 times of minus h plus 3k plus 2 whole square divided by 4, and here also 9 can be taken common. So we can write k plus 2 whole square is equal to 64. So 9 times of a square plus 9k square plus 4 minus 2 3s are 6hk, and again plus 2 2s are 4 3s are 12k, and again minus 4h plus again 4 9s are 36 times of k square plus 4 plus 4k, which is equal to 64 into 4, 256. So here 9 times, or 9 we can take overall common, h square plus 9k square minus 16hk plus 12k minus 4h plus 4, and again here plus 4 times of k square plus 4 4s are 16, and again here 4 4s are 16k is equal to 256, or 9 times we can add h square, and here 9k square plus 4k square is 13k square, and we got only 116, so 16hk, and again sorry, this is 6hk. So this is 6hk. So and again plus gamma x, here we can write x minus 4h and here we can write k times is 16k plus 12k, that is 28k, and remaining constants is plus 4. So I can take separately, 9 4s are 36, and again 20, 6 9 to 180 we can take, 16 plus 4 20, 29s are 180 is equal to 256, or we can also write it as 9 times of, by considering h comma k as x comma y, since h comma k is a locus considered, so we can write x square plus 13y square minus 6xy minus 4x plus 28y, and here 180 minus 256, we can write minus 76, which is equal to 0. Now comparing with the given equation, we have alpha is equal to 13, beta is equal to minus 6, and gamma is equal to minus 4. So that alpha minus beta minus gamma is equal to 13 plus 6 plus 4, which is equal to 23. So 23 is the answer, which is option C. Given a set A is equal to ordered pairs x comma y belongs to R comma R such that mod of x plus y is greater than or equals to 3, which implies that x plus y is greater than or equals to 3, or x plus y is less than or equals to minus 3. Since we know the inequality, mod x is greater than or equals to a implies x is greater than or equals to a, or x is less than or equals to negative a. So here in this case, we can say the line x plus y is equal to 3, this line with the positive intercepts, so 3 comma 0 and 0 comma 3, and x plus y less than or equals to minus 3, so x plus y is equal to negative 3 with the negative intercepts on x-axis and y-axis. So here we can say minus 3 comma 0 and 0 comma minus 3. And now the solution is x plus y greater than or equals to 3 means which is away from this, which is not passing through the origin, and x plus y less than or equals to 3, we can say below the line. Both are not passing through the origin. And coming to the set B, set of ordered pairs x comma y such that mod x plus mod y less than or equals to 3. So here we can write x plus y less than or equals to 3, or x minus y less than or equals to 3, or negative x plus y is less than or equals to 3, or negative x negative y less than or equals to 3. So these are the four straight lines. We can see that the first line x plus y less than or equals to 3. So this is x plus y is equal to 3, and less than or equals to 3 means it is passing through the origin. So we can say this side. And the next line x minus y less than or equals to 3. So with the positive x intercept and negative y intercept, so here is the line. So x minus y is equal to 3 is the line here, and less than or equals to 3 means which satisfies the origin. So we can say the solution will be this side. And negative x plus y with the negative intercept and positive y intercept, so we can say this is the line. Negative x plus y is equal to 3. So here also which passes through the origin. So, and next negative x negative y both negatives, so this is the line. So it is also satisfying with origin. So we can say that all these four lies inside and touches the lines passing through the origin. And third one, C, x comma y such that it's the intersection of the both A and B, where either x is equal to 0 or y is equal to 0. x is equal to 0 is y-axis line and y is equal to 0 is x-axis line. So you can see that the common solution of the both set A and set B, we can find 3 comma 0 minus 3 comma 0 0 comma 3 or 0 comma minus 3. So we need to collect the points which are common and also only in the either in x-axis or y-axis. So these are the 4 points. And now the summation mod of x plus y, where x comma y belongs to the set C. We can write it as mod of 3 plus 0 plus mod of minus 3 plus 0 plus mod of 0 plus 3 plus mod of 0 plus of minus 3, which is equal to 3 plus 0 mod 3 is plus 3. Again minus 3 plus 0 minus 3 mod is plus 3, and again here 3 and here also 3. So 3 into 4, 12. So we can say the answer is 12, which is option C. Given the parabola y square is equal to 4x plus 16, whose focus of this parabola is the center of the circle C of radius 5 units. So let us find the focus of the parabola. So it is in the form of y minus 0 whole square is equal to 4 times of x plus 4, that is x minus of minus 4. So we know that y minus k whole square is equal to 4a of x minus h is a parabola whose focus is h plus a comma k. So here the vertex is h comma k. So in the given parabola, we have the vertex. The vertex is minus 4 comma 0, and when comparing with a, the value of a is equal to 1. So we can write the focus is minus 4 plus 1 comma 0, that is minus 3 comma 0. So here we can write the focus of the parabola is minus 3 comma 0 and the vertex of the parabola is minus 4 comma 0. Since the center of the circle is focus, so we can say the center is center of the circle minus 3 comma 0 and the radius of the circle is 5 units. So we can write the equation. We know the equation with center radius form x minus h whole square plus y minus k whole square is equal to r square, where h comma k is the center. So here we can write x minus of minus 3 whole square plus y minus 0 whole square is equal to 5 square, that is 25. So we can write x plus 3 whole square plus y square is equal to 25. So this is the equation of a circle. And now the values of lambda for which the circle C passes through the point of intersection of the lines 3x minus y is equal to 0 and x plus lambda y is equal to 0. So here are the two line equations. 3x minus y is equal to 0 and x plus lambda y is equal to 4. The circle is passing through the point of intersection. Let us find the point of intersection of these two lines. So here y is equal to 3x. Substituting here, so we'll get x plus lambda of 3x is equal to 4. So x taken common, 1 plus 3 lambda is equal to 4. So x is equal to 4 upon 1 plus 3 lambda. So that y is equal to 3 times x, that is 12 upon 1 plus 3 lambda. So x is equal to 4 upon 3 plus lambda, 1 plus 3 lambda, and y is equal to 12 upon 1 plus 3 lambda. Let us substitute in the circle equation to get the point of intersection. So we can write 4 upon 1 plus 3 lambda plus 3 whole square plus 12 upon 1 plus 3 lambda whole square is equal to 25, or we can also write 4 plus 3 plus 9 lambda upon 1 plus 3 lambda whole square plus 144 divided by 1 plus 3 lambda whole square is equal to 25. And simplifying, so you'll get 7 plus 9 lambda whole square plus 144 divided by 1 plus 3 lambda whole square is equal to 25. So the numerator we can write 81 lambda square, and here 7 sevens are 49 plus 2 nines are 18, 18 sevens are, so we can write 126 plus 144 is equal to 25 times 1 plus 3 lambda whole square, we can write 1 plus 9 lambda square plus 6 lambda. So this can also be written 81 lambda square plus 126 lambda plus 144 plus 49. We can write 193, which is equal to 25 plus 25 9 times 225 and 25 6 times 150 times lambda. Upon simplifying, we can get 225 lambda square minus 81 lambda square plus 150 times lambda minus 126 lambda and plus 25 minus 193 is equal to 0, which is equal to 144 lambda square and plus 24 lambda minus 168 is equal to 0. 24 you can take common, lambda square 24 6 times and 1 time lambda minus 24 7 times is equal to 0. So we can write 24 times, or we can remove the 624, 6 times lambda square, and 1 lambda we can write it as 7 times lambda minus 1 times lambda, 6 times lambda minus 7 is equal to 0. So 6 lambda taken common, 6 lambda plus 7 minus 1 taken common, 6 lambda plus 7 is equal to 0. So we can get 6 lambda plus 7 into lambda minus 1 is equal to 0. So here we can say 6 lambda plus 7 is equal to 0 and lambda minus 1 equals to 0. So we are getting lambda is equal to minus 7 by 6 and another lambda is 1. Since lambda 1 is smaller than lambda 2, let us consider lambda 1 is equal to minus 7 by 6 and lambda 2 is equal to 1. Now we need to find 12 times lambda 1 plus 29 times lambda 2, which is equal to 12 into minus 7 by 6 plus 29 times of 1, so which is equal to negative 14 plus 29, which is 15. So we can say that 15 is the answer. The number of ways 5 boys and 4 girls can sit in a row so that either all the boys sit together or no 2 boys sit together. So here total 5 boys and 4 girls are there. So the first possibility, all boys sit together. Or the second case, no 2 boys together. So in the first case, we can say, let us consider all the boys as B1, B2, B3, B4 and B5, and the four girls can be taken G1, G2, G3 and G4. Since all the boys are together, let us make as a one unit for the boys and the girls as the separate units. So totally we can see that there are 1, 2, 3, 4, 5. 5 boxes are there. So all these 5 boxes can be arranged in 5 factorial ways. And again, the boys which are in the first box, this 5 box can also be arranged internally in the inside the box in 5 factorial ways. So which is equal to 120 into 120, that is 14400. And similarly, no two boys together in the second case. So here let us consider, first we'll fix the girls G1, G2, G3 and G4 so that we can find some gaps in between them. We have 5 gaps are there. So in these 5 gaps, 5 boys can be arranged. So the girls can be arranged in 4 factorial and the boys can be arranged in 5 factorials. So 4 factorial is 24, 5 factorial value is 120. So 24 into 120 we can say 2880. So either the first case or the second case. So which implies that required number of ways is equal to 14400 plus 2880, which is equal to 17,280. So 17,280 is the answer. Given the roots of the quadratic equation 3x square minus px plus q is equal to 0, 10th and 11th terms of, that is A10 and A11 of an arithmetic progression whose common difference is given 3 by 2, and also the sum of the first 11 terms of an arithmetic progression is given 88. Then we need to find the value of q minus 2p. So we know that sum to n terms in arithmetic progression n by 2, 2a plus n minus 1 into d. So we can write 11 by 2 into 2a plus 11 minus 1, that is 10 times of d, which is equal to 88. So here 2a plus 15 is equal to 88 into 2 divided by 11, that is 2a plus 15 is equal to 16. So 2a is equal to 16 minus 15 is 1. So a value is 1 by 2. So we got a value 1 by 2 and d value is 3 by 2. So we can find a10, that is a plus 90, which is equal to 1 by 2 plus 9 times 3 by 2, that is 27 plus 1, 28 by 2. Also a11 is equal to a plus 10d, which is equal to 1 by 2 plus 10 times of 3 by 2, that is 30 plus 1, 31 divided by 2. So let us consider the quadratic equation whose sum of the roots which is minus b by 8, so that is minus of minus b divided by 3, we can write p by 3. So here sum of the roots is a10 plus a11 is equal to p by 3, that is 28 by 2 plus 31 by 2, which is equal to p by 3. So we can write 59 divided by 2 is equal to p by 3. So p is equal to, we can write 177 divided by 2. Also the product of the roots, is c by a, that is q upon 3. So here we can write a10 into a11, which is equal to q by 3, that is 28 by 2 into 31 by 2, which is equal to q by 3. So here 2 2s are 4, 4 7 times, so 7 into 31 is 217, which is equal to q by 3, which implies q is equal to 217 into 3, so we can write 651. So we got the value of q 651 and p value 177 by 2. Now we need to find q minus 2 times of p, that is 651 minus 2 times of 177 by 2, that is 651 minus 177, which gives the value 474. So 474 is the answer. Given that alpha and beta are the roots of the equation, x square minus ax minus b is equal to 0. So we can say alpha square minus a alpha minus b is equal to 0 and beta square minus a beta minus b is equal to 0. And if I subtract these both, alpha square minus beta square minus of alpha minus beta of a and again plus 0, which is equal to 0. That is alpha square minus beta square is equal to alpha minus beta of a plus 0, we can write it as b into alpha power 0 minus beta power 0. So that alpha square minus beta square as given Pn is equal to alpha power n minus beta power n. So this is P2 is equal to P1 into A plus P0 into B. So we are getting a relation between P1, P2 and P0. Similarly, we can also frame the relation as Pn plus 1 is equal to Pna plus Pn minus 1 B. So that we can write P6 is equal to A times of P5 plus B times of P4, which is equal to A times of, and P5 value is given 11 root 7, B times of P4 value is given minus 3 root 7, and P6 value is 45 root 7i. So on comparing both the sides, it's all are imaginary parts, so we can write 45 and root 7 also can be removed. 45 is equal to 11a minus 3b. So this is one equation, and similarly we can also write P5 is equal to A times of P4 plus B times of P3. So P5 is 11 root 7. I is equal to A times of P4 value is minus 3 root 7 I plus B times of P3 value is minus 5 root 7 I. So on simplifying, we can get 11 is equal to minus 3A minus 5B. Now solving the equation A and equation B by using cross multiplication method. So we can write A upon minus 3 into 11 minus 33 and 45 into 5 negative of negative, that is plus 45 5 times 225, which is equal to B upon 45 into 3. So you'll get minus 135 and again minus 121 11 11s are, which is equal to 1 upon 11 5s are 55 and minus of minus 3 into 3 9. So that is 1 upon 64. So A is equal to, so 225 minus 33 is 192. So we can write 192 divided by 64, which is equal to 3. Now B is equal to negative 135 negative 121. So that is negative 256 divided by 64, which is equal to negative 4. So we got A value as 3 and B value is negative 4, and we need to find mod of alpha power 4 plus beta power 4. So we can also write it as alpha power 4 minus beta power 4 whole square plus 4 times of alpha power 4 into beta power 4. So alpha power 4 minus beta power 4 is nothing but, we can say this is P4 whole square plus 4 times of alpha beta whole power 4. And we know if alpha beta are the roots and product of the roots can be given by alpha beta is equal to negative B divided by 1. So negative B, which is negative of negative 4, which is equal to 4. So alpha beta value is 4 and also P4 value negative root 3 7, negative 3 root 7 I and whole square, we can write minus 3 whole square is 9 and 7 root 7 whole square is 7 and I square value is negative 1. So we can write negative 63. So which is equal to negative 63 plus 4 times of 4 power 4, that is root of negative 63 plus 4 power 5, it is 1024. So which is root of 1024 minus 63 is 961. Square root of 961 is 31. So we can say the answer is 31. We need to find the variance of the numbers 8, 21, 34, 47 and so on. Last number is 320. We can say that they are in arithmetic progression with a common difference 13. The last term is 320 and the first term is 8. So it's a general term, an is equal to a plus n minus 1 into d. So if I consider the last term, 320 is equal to 8 plus n minus 1 into 13. So we can write 320 is equal to 8 plus 13n minus 13. That is 325 is equal to 13n. So we can write n is equal to 25. So we got the number of terms is 25 and the general term can also be written as an is equal to 8 plus n minus 1 into 13. Or we can write 8 minus 13 is minus 5. So 13n minus 5. Now to calculate the mean, sum of these numbers, observations, that is sum of 25 numbers, which is equal to 25 by 2. We know that Sn is equal to n by 2 into a plus l, first term plus last term. So here first term is 8 and last term is 320. So we can write 325 into 328 divided by 2, that is 164. 25 into 164 is the sum of the numbers, and to get the mean, so we have to write mean is equal to sum of the observations by the number of observations, which is equal to 25 into 164 divided by 25. So you're getting 164. So this is mean. Now to calculate the variance, we need summation x square, that is 8 square plus 21 square plus 34 square and so on up to 320 square. So which is nothing but summation of its nth term is 39 minus 5. So we can have 39 minus 5 whole square, which is equal to 169n square, and here minus 130n plus 25 summation, which is equal to 169 times summation n square minus 130 times summation n plus 25 times summation 1. That is 169 into summation n square is n into n plus 1 into 2n plus 1 divided by 6 minus 130 times summation n is n into n plus 1 by 2 plus 25 times summation 1 is nothing but up to 25 numbers are there, so we can write 25 into 25. That is summation n we can write. Summation 1 is nothing but n. So let me write n here. Now let us substitute n is equal to 25. N is equal to 25. We have 169 into 25 into 26 into 51 divided by 6 minus 130 into 25 into 26 by 2 plus 25 into 25. So we can take 25 common. So we can write here 2 13 times and 3 times and 3 17 times. So 169 into 13 into 17 minus here 130 into 13 plus 25. Upon calculation, you will get the value 35,684. This is summation xi square. Now the variance formula is summation xi square divided by n minus mean square. So which is equal to 25 into 35,684 divided by 25 minus 164, mean is 164 whole square. So we can get 35,684 minus 164 square value is 26,896. So after calculation you will get 8,788. So we can say that 8788 is the variance.